Hi, this lecture is about Delta Lake. The objectives are create a Delta table, understand the transaction log, read data from your Delta table, update data in your Delta table, access previous versions of table using time travel and vacuum. So first we had run the classroom setup, create a Delta table. Let's first read the Parquet format, bedbricks events dataset, and we are reading it with spark.read.format parquet.load and the file path name. We are displaying it. Write the data in the delta format to the directory given by the delta path, and we are writing it into the delta path with the dataset eventsdf dot write dot format delta dot mode override dot save delta path. Then we are writing the data in the delta format as a managed table in the metastore. How we are doing it? The dataset eventsdf.write.format delta.mode override save as table delta events. As with other file formats, Delta supports partitioning your data in storage using unique values in a specified column, often referred to as Hive partitioning. Let's override the Delta set in the Delta path directory to partition by state. This can accelerate queries that filter by state. From pyspark.sql.functions import call state events is equal to eventdf.with column state call geo.state. Therefore, what is happening is that we are adding a new column called state, and then we are doing a format write in the format of delta.mode override, and then we are partitioning by state an option override schema true and dot save delta path. Next section, what we are doing is that understand the transaction log. We can see of how Delta stores different state partitions in separate directories. Additionally, we can also see a directory called Delta log, which is a transaction log. When a Delta Lake dataset is created, its transaction log is automatically created in the Delta log subdirectory. So if you do a dbutils.fs.ls of the delta path, you can see that there is a delta log directory that is being created, and all these are files. When changes are made to that table, these changes are recorded as ordered commits in the transaction log. Each commit is written out as a JSON file starting with a number of zeros.json. So when I do a display of the dbutils.fs.ls delta path of the delta log, we see that there are the 0.json as well as the 1.json. Let's look at the transaction log. The four columns each represent a different part of the very first commit to the delta table, creating the table. The add column has statistics about the data frame as a whole and individual columns. The commit info has useful information about what the information was, write or read, and who executed the operation. The metadata column contains information about the column schema. The protocol version contains information about the minimum delta version necessary to either read or write to this delta table. So this is says 0.json, and we are reading it, and it has got 7 rows. Next we are reading the 1.json, and the difference that you see, there are 206 rows. So it has, the log has increased, and the log has increased because of the partition by state. And if we look at the commit info column, and if we go to the operation parameters section, the partition by has been filled in by the state column. So what we have done is that I have taken the uh, commit info and I have put it in a separate file, and then you can see the partition by state. So this 1.json has this. So another thing that is to be noted is that if we look at the add section on row 3, we can see a new section called partition values has appeared. So partition values has appeared, and if I go to the add.json and if I go here, so partition values has appeared, and this is the state AK is there, and from there you can see that different partitions are present here. So first let's look at the files inside one of the state partitions. The files inside corresponds to the partition commit file01 in the delta log directory. So this is for the CA directory, that is California. Thank you, bye. Read from your delta table. df is equal to spark.read.format delta.load delta path, and we can display the data frame. Update your delta table. Let's filter for rows where the event takes place on a mobile device. Here the dataset.filter and the column device is in Android and iOS. And we can see that this is the updated dataset. And then what we are doing is that we are overwriting the updated dataset into the delta path again. And then we are reading the dataset again by the spark.read.format delta.load delta path. Let's look at the files in the California partition post update. Remember, the different files in this directory are snapshots of your data frame corresponding to different commits. So these are the different files. So these are the 8 rows that are there, and you can see that there are 8 rows now, and previously when I did the California one, if I go 8, there were 4 rows. So because of these commits, there are now 8 rows. Access previous versions of table using the time travel. So what is happening? We'll first drop the table if exists train delta, create table train delta using the delta location delta path. When we are doing a history of the train delta, we are seeing that there are 3 versions. The first version was very simple, and then it is partitioned by state, and then the second version. So 0, 1, 2 version. Using the version of option allows you to access previous versions of our delta table. So we can use version of 0 and we can load the delta path. You can also access older versions using a timestamp, and we can do it by the option timestamp. If I give the option timestamp in read format, I can do it. Vacuum. Now that we are happy with our delta table, we can clean up our directory using vacuum. Vacuum accepts a retention period in hours as an input. By default, to prevent accidentally vacuuming recent commits, Delta Lake will not let users vacuum a period under 7 days or 168 hours. Once vacuumed, you cannot return to a prior commit through time travel. Only your most recent Delta table will be saved. We can work around by setting a Spark configuration that will bypass the default retention period check. So that is spark.databricks.delta.retention duration.enabled is false. And then we are making delta table.vacuum 0. Now if we display look at the CA files, we can see that it is containing only the most recent commit. Since vacuuming deletes files referenced by the delta table, we can no longer access past versions. So that is what it is giving. So thank you. Hope you liked the lecture of Delta Lake. Bye.